All right, so part 2, 6.1, we're continuing to solve equations. We're just going to introduce more fractions today, actually. We're going to learn how to work with fractions a bit more. I find that in high school math that a lot of students just kind of get tripped up on fractions. So we're going to do our very best to get lots of practice with this, okay? Now, we had a couple questions on the worksheet in part 1. We had a couple questions that had to do with fractions. We went over those. We're going to do some more questions like that here today. So, solving equations with fractions. All right, hopefully you can, I might zoom in just a bit here. All right, no, that's too much. Okay, the easiest way to solve equations which contain fractions is to eliminate the denominator. All right, so if you have a fraction, like in this example 1 way down here, we have x over 12 equals 1 over 3. Yep. Am I still on freeze up there for you? Oh, I'm sorry. There you go. Did it feel cold in here? Okay. I'm so frozen up here. You like that? Okay. So usually the tough part about fractions is that there's a number underneath in the denominator there. So in solving, what we want to do is we want to eliminate the denominators. And we had a little bit of practice on that. So to solve equations containing fractions, each term, or multiply each term by the whole number that you choose. So you get to choose a number, and we're going to multiply every term by this so that we eliminate the fractions in the equation. Now, this number that we multiply all the fractions by must be a common multiple. Let's put multiple there. Multiple for all of the denominators. The denominators in the equation. So remember, we have numerator on top, numerator, and denominator on the bottom. So that's how a fraction works. That's how you name the top and the bottom. And in this example down here, multiples, I think I have to zoom in. That just seems a little small to me today. So the multiples of 12, let's say, we always start with 12 times 1 is the first multiple. We don't go smaller. There's no multiples of a number that are smaller than the number. Those are factors. So we kind of get factors and multiples mixed up. Factors are smaller than the number. Multiples are bigger. Okay? Think of multiply, getting bigger. Multiply. So we go 12 times 1 would be the first multiple. That's 12. 12 times 2 would be the second multiple. 12 times 3, the third multiple, and so on. For the multiple, or for the number 3, the multiples are 3 times 1, 3, 2, 6, 9, 12, 15, 18, and so on. So when you look at the denominators, you want to multiply by the lowest common multiple. The LCM, lowest common multiple. That's what you multiply by in order to eliminate all of the fractions. Now, could you multiply by any multiple? Yes. But if you multiply by a large multiple, then you're going to have a lot of like big numbers, and you're going to have to reduce the fractions or whatever, reduce the numbers, do lots of big dividing. So you don't want to multiply by too big a number if you don't have to. So in this case, the common multiple for the numbers 12 and 3 would be 12. It's the number that shows up on this multiple list. That's the same for both lists. It's the first one that shows up. That's the same. So let's take a look at example 1 then. Solve each equation by eliminating the denominator first. Okay, we did this a little differently in our worksheet from last day. We would have multiplied by 12 to get rid of this one, then multiplied by 3 to get rid of this one. We're going to now do this all in one step. So watch this. The common multiple between 3 and 12 is 12. So if we multiply everything by 12, that is the left side and the right side, then we are going to get 12 divided by 12 is 1. So that's just an x left over here. And notice that when you multiply a number times a fraction, you can simplify a number on top that is multiplied on top and a number on the bottom. So 12 over 3 becomes 4 over 1. You guys see that? All right. So you may work that out a little differently. You might say, well, I want to multiply 12 times 1 and just put 12 there. and 12 over 3 clearly is 4. So you could do it like that too. This way is a nice way to, because this number is not always going to be 1 on the bottom. So now I have, and this is, you got to be careful here, these 12s are gone, so I only have the x left on the left side, and everything else is gone. The 12 and the 3 have disappeared, and I have a 1 and a 4 left. So guess what? On this side, I have 1 times 4, or 4. Okay, now let's check that to make sure that's reasonable. So 4 over 12 equals 1 over 3. I just put my answer in there. And I can reduce 4 over 12. That 4 divided by 4 is 1. 12 divided by 4 is 3. So that 1/3 does equal 1/3. So that checks out. X equals 4 is my answer. Okay? So multiplying everything, every term, by the lowest common multiple of the denominators is super important, and that's what we're working on today. So B, let's take a look at B. Now 9 and 27. Okay, well, the multiples of 27, well, are 27, 54, and so on. I won't go any more than that because the multiples of 9 are going to be equal to 9, 18, 27. Oh, I've found something that's common. 27 is the lowest common multiple. You see that? So I'm going to multiply everything by 27. 27. And so here's where I do have to simplify some fractions again on the left side. 27 over 9 is the same as 3 over 1. So I've got 3 times -1 on the left side. That's -3. So whatever's left, you shouldn't have any denominators left, by the way. You shouldn't have anything in the denominator if you've done this correctly. So 27 on the right side divides with 27, so I do have 3x over here. And then everything kind of reverts back to what we did yesterday, and we divide by by a positive 3 to get rid of the 3 on the x, and we have x equals -1. And a quick check here will look like this. -1 over 9 equals 3 times -1 over 27. Well, 3 times -1 is -3. And when you simplify this, that's 1 over 9. So -1 over 9 equals -1 over 9. That's our answer. All right, how are you feeling about this so far? Everybody, is this 5 out of 5 easy? 4 out of 5? 3, 2, 1? What is it? Show me a hand. Show me a hand. Show me how many fingers. Okay. 4, 5. See lots of 4s and 5s. That's good. Some 3s. That's okay. We're getting lots of practice here. Oh my goodness. This is a tough one now because I have more than just 2 fractions. I wonder if the same rules would apply. Do you think the same rules would apply? Should I multiply by a common denominator or a lowest common multiple, I guess, of all the denominators? Yes. Now it gets a little tricky to figure this out. You can just go 4 times 5 times 2. You can just do that because 4 times 5 times 2 is a multiple of all 3 of those numbers. By definition, you're multiplying. But it's maybe not the lowest one, right? So let's see. You don't have to do this every time, but this is just helpful when we're learning. So the multiples of 4 would be 4, 8, 12, 16, 20, so on. The multiples of 5 would be 5, 10, 15, 20, and so on. Hey, this is looking good. The multiples of 2, 2, 4, 6, 8. Who do we appreciate? Me. Mr. Maxwell. 14, 16, 18, and 20. Hey. Oh. Wow. Okay. Do you see 20 there? All right, you see 20? So you could multiply it by 4 times 5 is 20 times 2, 40. 40, and guess what? 40 is another one. 40 is another one that's on both these lists, but it's not the lowest. So you're going to have some big numbers to deal with. Not the end of the world. You could multiply by 40. That would get rid of all the denominators, but then you're going to have to do some dividing later. So if we multiply everything by 20, okay, this side by 20, and both of these fractions by 20. I don't have room there, so I'm just going to use brackets there. I'm going to multiply 20 in. So this is going to be 20 times x over 4. I'll just rewrite this so it's easier to see. 20 times 1 over 5 equals 1 over 2 times 20. And we simplify each term. 20 over 4 is 5. That's 5x. Plus 20 over 5 is 4 over 1. That's plus 4. And 1/2 times 20 is 10. All right. Everybody good so far? Now that seemed like a lot of work. This will get quicker as you do run some of these multiples in your mind. This will get a lot quicker, okay? But we want to end up with sort of an equation like this, because this one's pretty easy to solve, right? So we'll subtract 4, and I've got 5x equals 6, and divide by 5, x equals 6 over 5, or x equals 1.2. Either one are acceptable, decimal or fraction. So simplified fraction, great. Decimal, also okay, good. If you can get comfortable with fractions, that's best. So fractions would be best, just because, well, we want to get more comfortable with fractions as early as we can. All right, so any questions about that? Yep. Question? Okay. All right, next page. Flip your page over. Solving equations with variables on both sides. Okay, so this is a bit of a different look here too. Not hard, but we've got variables on both sides of the equation. So remember, when solving equations, our goal is to get the variable by itself. Therefore, the variable cannot be on both sides of the equation. We must get the variable on one side of the equal sign and all the constant terms on the other. And so we want to gather like terms. Remember like terms from chapter 5? Gather like terms. So take a look at this first one. I want to get the x terms all on one side. Good idea if you can. You don't have to do this every time, but if you can bring the smaller one over to where the bigger number is, you're going to be dealing with fewer negative signs, okay? You're not going to have to be working with a negative. Put that away, please. Minus 2x for both sides. Minus 2x. So bring the smaller one to where the bigger one is, because this is now going to be a positive x on this side. You see that? 3 minus 2. Those are gone. X equals 8. And as it happens, you don't have to do any more. That's it. X is by itself. It's positive in the numerator. We're good. A little check. 3 times 8 equals 8 plus 2 times 8. That's 24 equals 8 plus 16. Is that true? Yep, that's absolutely true. 8 plus 16 is 24. Questions? Yeah, question?
Why did the 3 and 3x just go away? Because you're right, they're minus 2.
Why did the 3 and the 3x just go away? Well, because we have 3x on the left side minus 2x. That equals 1x. And that's what I put right there. That's 1x. Yeah. So yeah, this is the same as 3 minus 2 is 1x. I just didn't put the 1. But it's 1x, and then you would just show it as just x. Does that help? Yeah. Okay, good question. Thanks for asking that. I'm glad you asked that, because yeah, somebody else might have that question too. Okay, any other questions? We're good? Okay. Let's see. I'm going to do one more and get you to do one of these. So which one do you want to do? You want to do B?
Yeah.
Okay, so you want me to do C?
Yeah.
All right. Okay, now, so I'm thinking about the W's on either side here, and if I subtract a W from the left side and subtract a W, I'm going to have negative 3W. If you have a negative variable, you have to divide that negative off later. So remember, where's the bigger one? Positive 1 is actually bigger than negative 2. So I'm going to bring the smaller value. I'm going to add if I can. So plus 2W to both sides. That's going to give me a positive 2W plus 1W is 3W. And those are canceled to 0. 3W equals 9. And so then what we're going to do is we're going to divide by 3. And we're going to have w equals 3. A quick check, 3 equals 9 minus, 2 times 3. That's 3 equals 9 minus 6. Yep, 9 minus 6 certainly is 3, so we've got that correct. All right, you go ahead and do B now. Do B on your own, right here. Okay, so for B, I'm going to add 3x to both sides. I'm going to have 16 equals 8x, because 5 plus 3 is 8. So 8 x's. Divide by 8. X equals 2. Got it? Yepers. Okay, good. And that should check out as well. All right. Okay, so I am going to let you do these two on your own, and we're going to skip to the next page. I know, sad, isn't it? All right, more solving equations on variables on both sides. Whenever you have a variable on both sides of the equation and a constant term on both sides of the equation, you will need to use the... Yes, well, actually, technically this is going to be a 0. You're going to need to use the 0 property. Now, what I'll show you. Remember we did this with the algebra tiles, where you have a positive 5 and a negative 5. It's like you cancel out. That's really what we've been doing. So it's basically using the inverse operations. We're going to have to do that twice. Okay. The 0 property is where you have a negative something and a positive of the same thing, and that equals 0. That's what it means. Okay. And this could be any number or variable or term. That's the 0 property. So it's just kind of what we've been doing. One time you'll get rid of the constant term from the one side, move it over. And the other time you'll get rid of the variable term, okay, from the other side. In an example like this, our goal is to get all constant terms to one side of the equal sign and all the variables to the other side of the equal sign. So just what we've been doing, except you got to do things more than one time now. Just keep going until you got x isolated. So in this example 3a, I'm going to add 3x to both sides. Add 3x. And you can actually, if you want, if this is not too much for you, I would love it if you also moved the constant in the same step. So you can do that. So you can subtract 7 from both sides as well. Now this will end up looking like this. 4 plus 3 is 7x. 7 minus 7 is gone. 21 minus 7 is 14. And negative 3x plus 3x is gone. So we've done those two steps all in one go. And I'm okay with that. If you can do this, go for it. All right? If that's too much, if that confused you, all right, I'm just going to bring this down here because that's where we want to end up. I'm going to redo this again real quick, and we can do one thing at a time. No problem at all. Let's subtract the 3x from both sides, and we're left with, add 3x to both sides. We're left with 7x plus 7 equals 21. Then, secondarily, we will minus 7 from both sides and end up with 7x equals 14. So you can do that twice, two separate steps, if that helps you. So 7x equals 14. Let's divide by 7. And we've got x equals 14 divided by 7 is 2. All right, a quick check. 4 times 2 plus 7 equals 21 minus 3 times 2. That's going to be 8 plus 7 is 21 minus 6. That's 15 equals 15. Excellent. So x equals 2 is your answer. Michael.
So how would you decide, like in that first step,
Yep.
you added 3x?
Yep.
How would you decide which one to add, like plus 4 or plus 4?
Okay. Yeah, okay. So how did I know to add 3x to both sides and not subtract 4x from both sides? Yeah, you can do either one. But remember what I said earlier, bring the smaller one over to where the bigger one is, or eliminate the smaller one. So if you have to, this negative 3 is smaller than 4. So I would bring this term, really what you're doing is you're bringing this term right here over to the other side. And when you do that, it turns into the opposite operation. Now, if you can add something to both sides, that's preferable. It just takes one more step away later. But if you subtracted 4x, Michael, and then you subtracted 21, you would have negative 14 equals negative 7x. No big deal. You'd still get the same answer. But you wouldn't have a negative to deal with. That's all. So it's just a little kind of tip. And once you do more of these, you'll see that. Like, oh, that's actually pretty smart. It saves me a bit of time. Okay, next one up. B. Let's do B over here. So B. So you know what, Michael? I'm not even going to think about it right now. I'm going to just bring the variables to the left side, no matter what, and the constants to the right side. So actually, this is going to work out pretty good. So if you want to bring the variable always to the left side, if that makes more sense to you, then go ahead and do that. But this one's very similar. And so I'm going to add 3x to both sides. That's gone over there. And then I'm going to subtract 10 from both sides. And these two are gone. So again, that's doing two steps at once, which you're more than welcome to do. So this I can combine. 2x plus 3x is 5x. That's going to be 0. 20 minus 10 is going to be positive 10. And that's what's left on this side. You see that? So divide by 5, x equals 2. I got x equals 2 as well there. All right. Any questions about either of those first two? These are all great questions, by the way, you're asking. I appreciate that. Okay, do C on your own. Do C on your own, either in two separate steps or you can do two steps at once, as long as you have it all straight in your mind. Bigger numbers here now. Okay, so get the variable terms on one side, the constant terms on the other. All right, so again, I'm just going to bring the variable over to the left side here. I'm going to add 6y. And I'm also going to, at the same time, get the constant to the other side. So I'm going to do the opposite operation of 53. And in that way, these constants are gone on this side. See, constant's gone. And over here, the variables are gone. They've left. And so simplifying here now, I can do the y terms. That's going to be 7y plus 6y is 13y. And these are gone, so that's great. 14 minus 53. Ooh, that's a tough one. What's 14 minus 53? Negative 39. I like that. And then these are gone. Ooh, so 13 was a rough one. I thought, oh, we're going to have a fraction here. But wonderfully, 39 is evenly divisible by 13. I love it. Math is just so happy with this question. What's 39 divided by 13? 3. So it's negative 3. Don't forget about the little happy negative sign there. Actually, can the negative signs be happy? I don't know.
They're always negative.
The sad negative? Yeah, they're always negative, like pessimistic, hey? The sad little negative sign. That's too bad. Well, I guess math's not totally happy with this question, because we have a negative sign in it. Let's see, does this work? Let's check this puppy here. So 7 times negative 3 plus 53 equals 14 minus, what was that? 6y? Minus 6 times negative 3. Wow, this is going to be a tough one. Negative 21 plus 53 equals 14. Negative times a negative, that's a plus 18. So 53 minus 21 is going to be 32. And 14 plus 18 is going to be 32. Wonderful. So negative 3 does check out. Question? Yes?
So do we, like, for the non-variable one, do we just take the one with the sign? Like, we always minus the dy, we can't just do minus 14.
Okay, so so I think your question is, if you, like, what I first started with was eliminating the variable term on one side. I got this variable term, I got it to the other side. I kind of think about, if I'm going to bring it to the other side of the equation, I have to flip the sign. That's exactly what you're doing. So I brought this over here. Now, there's no sense for us to do this. If you got 13y here, there's really no sense for you to also bring the 14 over. Do you know what I mean? So if we eliminated everything from the right side, you could still get the right answer. You could still get the right answer. It's just a long way. So watch this. We have 13, and then this is plus 39 equals 0. So if you are moving around the terms and you end up having both the constant and the variable term on the same side of the equation and you just have 0 on the other side, no problem. Don't panic. Just focus again on your job. What's your job? To get the variable by itself. So now you go, oh, I'm actually going to have to add minus 39 to both sides, and I'm going to get 13y equals negative 39, and then boom, you've saved it. Now you still get the right answer. Okay? So if you end up moving the terms and you move everything to one side and let it equal 0, no problem. Just get rid of the constant term to the other side, isolate that variable. So I think that was your question. Is that your question? No problem. You can still save it. It's just going to be an extra line of work. So I'm just trying to help you guys to choose the most efficient path here when solving. But yeah, if you do things just a little differently, you can still get the right answer. It just might take another step or two. All right, I want to get you to do these two on your own. This is the last little bit of part 2. So go ahead and do these questions on your own, and I will show you the answers in about 5 minutes. And I'll hand out the 6.1 worksheet number 2. And that's what we'll begin working on for the rest of the class. So go ahead and do D&E right now. All right, so here's the answer for D. Again, I brought everything over to I brought the x terms over to the left side, and I brought the constants over to the right. Please show your checks for every question we do in their notes package here. So here's the check for x equals 1. That seemed to work. So if the check checks out, then you've got the right answer. Now with E, okay, there's a couple things here. You do have to distribute first. So I multiplied 3 in to all the terms of the brackets and got 3x plus 3, and multiplied 5 in and got 5x minus 5. Now, I just brought the variables over to the left side. I didn't worry about which was smaller and bigger. So you don't have to worry about that really, because this is what it looks like. If I bring the x terms over to the other side by subtracting 5x, am I on free still? I thought I hit the button there, guys, sorry. So if I bring the x terms to the left side, notice that I'm going to get a negative 2x here. So this is what I did. I subtracted 5x from both sides. And then I subtracted 3 from both sides to get a negative constant term. So it really doesn't matter, which side the variable goes on and which side the constants go on, because if you divide here by negative 2, you get x equals positive 4, and over here 4 checks out. So that's your answer, x equals 4. And this is an example of where you just bring the variables to one side, bring the constants to the other. It doesn't matter if it's positive or negative. That's fine. All right. Now, for those of you that want to do one step per line to make sure you got it straight, I totally encourage that. That's great. If you can do the 2 steps like I'm showing you here, then please go ahead and do that. Just do me a favor and show all of this work so I can see that you know what you're doing, so that you get this process ingrained in your head. Okay, any questions at all? Okay, I'm going to hand out worksheet 2. If you lose worksheet 2, okay, you can print them off on the website, mrmathwell.com, which is right here. Okay, here's your worksheets right here. That's 1, that's 2, and I've also got the 3rd one I'm going to give you later. So they're all right there.